Welcome everyone, it's the Crypto Lark. I'm very excited today to have the chance to talk with Ben from Elrond. Ben, how's it going?
Great to be here. It's great, sunny weather in Romania right now, and great to be a part of this and have this conversation.
Yeah, well, I was just looking on the map on the little town that you're in Romania. It's just this beautiful historical city in the mountains, and I love Eastern Europe. Such an amazing place. And of course, you're coming into summer, which is fantastic.
Yeah, exactly. It's really good weather, but the focus right now is on testnet, so no time for taking advantage
Walks
of
in the
that.
forest, just computer time. Now, before we do get into the interview, we're going to be breaking down just what Elrond is doing and all the different things about it. But just a reminder to everyone in the audience to always do your own research on any crypto project. Elrond is a very interesting project, but as always, if you guys want more information about it, there's links down below where you can check out their social media channels, engage with the community, or go over to the website and read the white paper, any of the other stuff. Also, like to give a massive thank you to the guys over at Elrond for supporting the channel by sponsoring today's video. Now, Ben, the thing we want to start off with, to give the high level, what are you guys doing? What is your elevator pitch?
Yeah, so with Elrond, we built this new blockchain architecture that essentially can bring a 1000x cumulative improvement in scalability or throughput, transaction speed, and transaction cost. So essentially, you can think of it of bringing broadband performance to the blockchain space. Of course, we all know how important this was for the internet as it transitioned from dial-up to broadband. Everything changed for the applications, for what you could build on the infrastructure. And so the same thing we think will happen to the blockchain space, because essentially everything is a matter of throughput, transaction speed, and transaction cost. At the end of the day, these are the measures which limit or enable you to build something very different.
Well, this is what's been holding dApps back. I mean, we have some blockchains now that are starting to make those inroads, but really, if we look at Ethereum, it's still 17 transactions per second, and it won't be more than that for a long time. And if you want to talk about big social media, big video games, stuff like this, we need real transaction speeds. We need real throughput that is big and secure, and that's what you guys are working on. Now, very exciting. You guys have launched your testnet. So your testnet is live. So how's that going? What have been the initial results from the testnet?
Sure. So we've been working on this for a long time. We started Elrond in October 2017, published a technical paper in May 2018, and this was actually the first full formalization of adaptive state sharding and secure proof of stake. After that, we released a prototype about 3 months after the publishing of the paper. We made the prototype open source in November, and after making the prototype open source, we essentially rewrote everything from scratch in order to improve the architecture a lot, and came up with a 30x improvement from prototype to testnet.
That's pretty substantial.
Yeah, it is. We anticipated like 5 to 10x, but 30x was extremely excited. So we were very happy to just showcase all this work and share the information with the community, try to underscore the milestone, which I think is extremely important, not only for the project, but also for the whole blockchain space. Because as we've seen, and if we look back a bit, Bitcoin was the first iteration, which essentially showed that you could do a transfer of value or ownership without the need for a trusted third party. This was extremely important for the whole space. Now, Ethereum was the second major iteration, which took off because it added smart contracts in addition to what Bitcoin could do. But I think we have reached a point where the limits of the architectures we've seen are essentially setting everything, limiting the whole space to this situation where you cannot use blockchain more than a toy, right? And we appreciate how important the technology is, but also appreciate that you need good enough performance for all these things to finally take off.
Mm-hmm.
So this has been the focus at Elrond. How do you not only discuss about it? And the first step was focus fully on creating this architecture, taking bits and pieces apart of what the blockchain means and re-architecting everything. So we can really bring a 1000x improvement, which I think changes everything if you can do it. So after that point, the whole focus was again on going through the hell of building this stuff, which is a totally different story. It's one thing to come up with a paper and like put a lot of interesting things together with math and formalize that, which is very difficult as a first step. But when you move forward, an even more difficult thing is to build that kind of stuff. And to take it one step further, when you want to make it a production ready architecture, that's like nightmare mode squared. So it was a very, very challenging journey, but also a very, very rewarding. Each step, you discover some new things, then you make sure they work, you put them in and so forth. So this has sort of culminated with a testnet release that we had, where we wanted to give an overview to the community of what the process looks like from the inside and what you go through and so forth, and also prepare them for a few of the next steps that will follow. So we are very, very excited to have this out. And right now we are at the point where essentially you have the state sharding problem and proof of stake problem solved. Right now, it will take a bit for the community to assimilate the information, to test the things, to understand the implications. And this usually takes a few months. But once this is out, we are already focusing on the next major problem, which I think everyone will solve, but we'll get to that in a moment, I'm sure.
Yeah, it's I think it's really important to underline that it takes time to build this technology, and we're changing so quickly. And, you know, back when Bitcoin was made, well, it was revolution at the time, and it's still amazing technology and it's still an amazing form of money, but we've moved so much beyond that in what we're building now. And one thing that has become very popular recently is, of course, sharding and sharding technology. Now, you guys are using something called adaptive sharding. So can you explain to the audience what is adaptive sharding? And there are a lot of other blockchains that are doing sharding. You know, Ethereum's looking at it, and Zilliqa's doing it. And so can you kind of explain how your approach is different to those other chains as well?
Sure. So I'll go step by step. The idea with sharding is that essentially you can partition the network into smaller networks in order to parallelize transactions. Now, in our case, you have three versions of sharding. The first one is transaction sharding. The second level is network sharding. And the third level and most difficult one, but also with the highest implications, is state sharding. Now, this was the idea from day one when we thought how we could improve things. And I'll take one step back just to give you the context. There was, you can come up with an incremental solution really fast. This is not a problem. You can improve like Bitcoin 2x or 3x in speed, or Ethereum 2x or 3x with some minimal tweaks where you do not put a lot of thought and so forth. The idea was for us it was clear that you would not get more than 3 to 6 months advantage with that kind of approach. And the only approach which would work would be one where you could come up with a radical improvement that could bring a 2 or 3 orders of magnitude improvement. So the only thing that we saw feasible to come up with this type of solution was state sharding, because it essentially, the whole importance of sharding is that you can parallelize transactions. Once while in Bitcoin or Ethereum, you have this process where everything is in serial mode. Here, you can parallelize transactions, and if you do it right, you can have a lot of throughput, like orders of magnitude. Now, coming back to the sharding types, as I've mentioned, there's transaction sharding, network sharding, and state sharding. This is the most difficult and has the highest implications, because what if you do state sharding, you assume that you also do network sharding and transaction sharding. So you take all the three problems and try to come up with a solution. And this helps the network a lot. Now, coming back to the adaptivity, the idea with Elrond's network was that if you can start a network and you know that you want throughput as the network grows, you also know that you do not want a static network where you just have a certain number of shards, and if some nodes leave the shard, then your shard can die just because it cannot satisfy the necessary security criteria anymore. So the only way to make this work, and the only natural way actually, is if you can start with a model that can start with only one shard and then can split into 2 shards, and then can split into those 2 can split into 4, and so forth in real time. And there's something very, very elegant there, where if you understand, you try to optimize for 2 things. The first one and foremost is always security. You want to make sure that you have a certain number of nodes in the shards, and whenever you have a number of nodes that is lower to the threshold that is secure, considered secure for that shard, then the shard can merge with the sibling shard in order to have a larger number of nodes and still maintain security. Now, at the same time, you also want to make sure that as more nodes join the network, you can use those nodes in the most optimal manner, meaning that the more shards you have, the more throughput you can parallelize, and the higher the overall throughput of the network is. So as you see, we want to make sure that you have security, highest level of security, and then at the same time you have the highest level of throughput, depending on how the network behaves, how many nodes you have, and so forth. But while this seem details, they can play a huge role further down the road. So this is why we thought it's not only important that we have the highest throughput possible by solving the most difficult problem, which is state sharding, but also try to come up with a network that can start small and grow as the community network penetration and so forth grows, and then maintain security, but also then considerably increase throughput as you penetrate the market, have a larger community, and so forth.
Well, that's
which I think is much more closer to a realistic scenario that works in practice.
Well, that's where the adaptive part comes, right? Is that as it grows, as the demand grows, you're able to grow with that demand, not have a static ability in terms of your transactions and your throughput and things like that, which the other blockchains did. And again, they were early versions of this technology, and you're building the future version of this technology, which is very exciting. Now, I saw that was it 3,750 transactions in one shard? Was that what was tested?
Yes. So the initial result in the testnet compared to the prototype results were 30x, in the sense that in the prototype we had 120 transactions per second per shard, and in the earliest version of the testnet we had 3,750 transactions per second per shard, which is a crazy improvement, but something that works. And we actually validated the whole hypothesis we mentioned in the paper, on the website, and so forth, that our idea was to come up with a solution that can process 10,000 transactions per second with a 5 seconds latency and then a minimal cost. And in the testnet we've just released, we have exceeded 10,000 transactions per second with only 5 shards. We will, of course, have a lot more than that, but this is just to give you an idea of what it means to build an architecture that works and then makes sense in a real world setting. Just try to think how a network with 20, 30, 50 shards would look like. So it suddenly dawns on you that you're playing a different game, and you can think of many use cases that suddenly make sense because you've reached a threshold where the performance of the blockchain space allows you to have a lower transaction cost than comparable centralized counterparts, which I think is a very key point.
Yeah, it's about trying to get to the capabilities of these more centralized services, but while still maintaining all of the decentralization that we come to demand, I think, in the crypto community. Now, that moves me on to my next question for you, and that's actually about your secure proof of stake. So you guys are running a proof of stake network. So can you kind of break down for us what is secure proof of stake? And also, do you have any details that you can share at this time about staking rewards or any requirements to actually be able to stake?
Sure. So the idea with secure proof of stake was, again, if you build a scalable architecture that you think will scale at a global level on the long run, and you have the parallelization of transactions, what you need is a very efficient consensus mechanism in terms of energy and computational use, and then a very fast consensus mechanism at that. So the obvious choice was that we wanted to depart from proof of work, which is very energy intensive and not sustainable, especially if you think you want to penetrate the market and have a really large network. So the obvious discussion moved toward proof of stake, and there were several versions there. The idea was that the first version was delegated proof of stake, but we've obviously seen several networks trying to launch a version of architecture which was based on delegated proof of stake. And the secondary effect, not immediately obvious, was that you had a network that after a certain threshold was reached would sort of collapse, in the sense that the network would start degenerating into cartel wars. So this means that at that point you reach a state where the network participants and actors do not have an incentive which is still aligned to still work on the network and bootstrap and contribute and so forth. So this was the obvious problem that we've repeatedly seen with delegated proof of stake. And then what we wanted was, as I've mentioned, a pure proof of stake mechanism that is decentralizing in nature. So as opposed to proof of work, where you have essentially an arms race happening, where over time, much more centralization, much larger players doing the mining part, and very few people being able to compete with them. In secure proof of stake, you have a system which allows you to contribute, but you have a bounded stake, which beyond a certain point does not affect your voting power. This means that if you have, let's say, there's a guy who has $100,000 and a guy who has $1 million, and in Elrond it costs about $200 to start run a node. Then it means that if you want to run more nodes, then or want to stake your whole sum, then you need to run more nodes. And if you as a starter want to join the network, this also means that you have a chance of contributing, doing the stuff and so forth. But coming back to the secure proof of stake part, so I mentioned why we departed from proof of work, also mentioned why we did not choose delegated proof of stake. Now, the idea was we have a pure version of proof of stake where you have this stake-based mechanism where you can join, and then after you have a stake in it, you can participate. Now, the most important thing for us was how do you do it in a very, very fast manner? Because you have stake as a Sybil attack prevention mechanism, essentially, so that you cannot construct unlimited or infinite identities and just flood the network. So the next point is we've done the fast consensus part through a modified version of PBFT, which essentially allows us to have a latency of 5 seconds. So this was the energy part, the rapidity of the consensus process. But then in addition to all this, the security part, we've been the first to propose a new and more robust security to the consensus, which means that you have random sampling of the consensus group to begin with. And to tell you this in practice, what it means is you have, let's say, 400 nodes in a shard, which are eligible to be part of the consensus group. And then the consensus group is randomly sampled from those 400 nodes and reshuffled randomly again every 5 seconds. This means that even if you would want to attack the consensus group, you have you first don't know who will be in the consensus group because the sampling happens randomly. But then even after you discover, you only have 5 seconds to do something there, and then the whole consensus group reshuffles. Now, to add an even further layer on that, we are doing nodes reshuffling with up to 1/3 of the nodes being reshuffled to other shards at the end of each epoch, which at this point is 12 hours. So again, you see not only throughput, but also very, very fast consensus speed, but then at the same time, very, very robust security. And we price this a lot because I think this is the point on which you can build for the long run.
That sounds like a very robust proof of stake network without a doubt, and it's I'll be love to see this on the mainnet actually working, bringing this massive throughput and making this happen. Now, one thing that is getting talked about a lot, even more than sharding right now in the cryptocurrency space, is the idea of interoperability. So everybody right now wants to be friends with Ethereum, so they're building bridges to Ethereum, or they're enabling the Ethereum virtual machine, or they're somehow making it so that Ethereum developers can come over to their chains. So how much of a focus is interoperability for Elrond?
We price this a lot. Also, we understand that this will be very valuable further down the road. The idea with us is we want to focus on bridging the gap between blockchains in several ways. The first obvious way is we've constructed a meta VM, which means that we've built on K framework, and this allows us to support 3 VMs at the same time. And those VMs are the EVM, Yele, and WASP. What this actually means in practice is that if people have written code in Solidity, they can run it on Elrond directly. So it is a very, very important step of welcoming developers and creating a very, very flexible toolkit for them. Now, a second step in that direction is a lot of discussions we are putting in coming up with a solution that connects to the interoperable bridges. Right now, there are a few options out there. We have our research going on right now, and we'll have a solution that will likely interoperate with some of them. We've obviously had some really good discussion with Cosmos. We like what they are doing, and the idea is that how we see things is you want one problem to be solved, and as soon as it's solved, you can focus on the next problem. If you focus on 4 problems at the same time, you will lose focus and also will not come with optimal solutions. So we focus very much to come up with the testnet and demonstrate that higher throughput is actually what is needed for real world adoption. And this is mainly because we have a lot of discussions with companies, and no company asks us, are you interoperable with a different blockchain or whatever? They're only asking, do you have high throughput so that I can really run an application on that? How much does it cost? How fast can I process things? If you enter that, then interoperability becomes something really nice to have, which can add a further layer of performance to what you are building. But if you don't have that, on the other hand, it doesn't add too much, because you can essentially process the same 7 to 15 transactions per second and so forth. So yeah, long story short, we want to have interoperability. We'll have it in Elrond, but the primary focus is to solve these problems, and then we can partner with everyone who wants to use the solution.
Be friends with everybody. Well, it's actually great to see that the main focus is on getting people to come and build with lots of transactions, per second, lots of throughput capability, cheap to build on. Now that actually takes me on to the next question, which is, is there anyone you can talk about yet that's building or looking to build, or any partners that you're lining up currently that we can disclose? And if you can't disclose them, can you kind of give us some hints of what we're looking at in terms of the industries and things like this?
Sure. So I cannot disclose the exact client, but I can tell you a bit of the discussion, what's happening, what we are discussing, what some of the main problems are they're tackling, and where Elrond comes in and what the solution is. One of the clients essentially is discussing about machine-to-machine transactions. I've been talking about this on Twitter and some other places as well. The idea is, if you take a case where you have self-driving cars, which is not a situation which is very far away, but rather very close to what we'll have in the near future, then what you understand is you need a way to transfer value without the need of a trusted third party. And at that, you need one who has a really high throughput, a very fast execution speed, and a very low cost. Otherwise, it does not make sense to put hundreds of thousands of cars, if not millions of cars, in such a network. So what's happening is that these companies have already created some pilot projects on Ethereum, and they see that it's very, very far to being usable in production, right? It's a nice way of doing the prototype, validating that the idea works. But exactly here is the point where Elrond comes in. We've seen, as I've mentioned before, that you can do transfer of value. We've seen that you can do smart contracts. But right now, we need to transition to the broadband performance I was mentioning. And if you have that, then the companies they can't wait to test that, especially if you offer them tools through which they can port their pilot project and so forth. So our idea is clearly to go and organize some hackathons with them, announce some information as soon as it's public. But and the discussions are very, very exciting. So everyone is looking at this point into how they can implement blockchain, and everyone has heard about the technologies, but no one has seen them in practice. So we want to be Elrond, the solution that not only tells you about the story, but it has the solution. We do a demo right then, and then the whole process is a different one, right? This is with every interesting idea. It's one thing for someone to tell you about what he can do in the future, and a very different situation to have the solution right now and demonstrate it to you. And then you can say, okay, when do we begin integration?
So that news about the partners is great, and obviously, when we do get to the point of getting that release, then it'll be very exciting to find out about that partnership. But what I really want to know is, I looked at the website and I didn't see any big venture capital firms, big investors named, and it's pretty typical you see that. So, can you tell us who are the big names that are backing you?
Mm-hmm. Sure. So we have several investors at this point. A few of them will not announce right now. We will probably release a press release pretty soon about this, but I can name a few. So it's NGC, Maven 11, Autorito. These are three funds that are in. We have others as well, and there's also a very significant group of people from the community, very strategically let in, because they provide a lot of value in different markets that we want to target and penetrate really, really fast. So yeah, I am really happy to have the guys in, and we'll probably announce some more things pretty soon in a press release.
Yeah, well, it's really important to have those strategic investors as well, because they can introduce you to markets and partners and all these things. And of course, venture capitals fill the role of that as well. And for anyone who doesn't know, NGC is Neo Global Capital, which is obviously one of the big venture capital funds in the entire crypto economy. Now, does that mean that there's going to be any kind of relationships potentially happening between Elrond and Neo?
Yeah, I don't want to comment too much on that right now. But yeah, we're open, and obviously, whenever we see someone building stuff, we will have lots of discussions behind the scenes. And whenever there's some communication we want to share, then we'll make sure that that things are in place and so forth. We want to take it one step at a time, and as soon as there's something exciting, we want to share it with the community, of course.
Yeah, very cool. Definitely, those are good backers to have, and I think it just really shows the quality of the project that you guys are doing. That you do have these big name backers willing to put their money on the line, so to speak. So very, very cool.
Yeah, so I do think that people start to understand very well what we are aiming for, and especially what kind of implications the technology can bring, and that these implications will also have economic implications. If the technology works really well and you'll see it adopted, then obviously there's also a very interesting role to play for the investors, both in terms of economics, but also in terms of strategy, market penetration, and just growing with the project that has so much potential.
Exactly. Well, that you've made such a great point that a lot of blockchains are a few years away from the delivery of this kind of technology, where you guys are ready to do it relatively soon, right? And that actually brings me to the next point, which is about the roadmap. Now, I was looking at the roadmap. I've seen a few different versions of it floating around on the website and other places, but it seems like, the main net will be happening this year. So by the end of the year, we will have a main net for Elrond. So I hope, I know if
A lot faster. So
oh, a lot faster. Excellent.
yeah, so we marched really fast and sprinted to have the testnet out, because the testnet puts you in a different setting, right? It's one thing to approximate and create a timeline while you're drafting a white paper, because it basically puts you in a situation where you have no idea other than some rough time estimates you can come up with, right? But then as you move and create the prototype, then it dawns on you that there are some interesting things out there. Some of you've thought really well, a few of those you've not thought about, and then you adjust that. But what we've said was we want to reach the testnet, because at that point things become a lot more clear. Then you can sprint really hard toward the mainnet. And we are now at the point where I would say something like 3 months. This is again a tentative time frame. We are putting a lot of effort into moving as fast as possible. But the main thing is that the transition from testnet to mainnet is not only a transition in terms of features, integration, and complexity you add, but most important, a transition in security level. Because you go through several stages of audits, stress testing, penetration testing, and repeat them in order to discover any kind of critical bugs or things that were missed in the process. And this is very, very critical for a production network, especially since it's blockchain, right? And to this end, we also have formal verification for the smart contracts, which I mentioned. So this will also help prevent some of the bugs when you write smart contracts, not to end up with losing hundreds of millions of dollars and so forth. So yeah, we are very excited to have reached the testnet, because the testnet essentially tells you that we are very close and much closer than anyone to the mainnet. And we can share this, can't wait to share this with the community, with the companies, startups, and so forth.
Very cool. Definitely looking forward to it. And I guess the last question for you, maybe this should have been the first question, but the last question for you, who is your favorite Lord of the Rings character?
Elrond. I cannot say anything else right now.
Amazing, amazing books. Tolkien's a
Lord of
genius.
the Rings is a really awesome story that everyone should read, because it's a story of how you start from one place, how life essentially is, and what you become by going through the stuff and still pursuing the right things.
And that vision, I think, is really being pursued with the blockchain technology that you're bringing out. And it's very exciting stuff. Again, for anyone who wants to find out some more information, go and read some of the technical papers or engage with the community, become a member of that community. There are the links down below, so you guys can go ahead and check that out. Thank you so much for coming on today. This has been super, super interesting.
Great being here, and again, great having this conversation.
Thank you very much.
Thanks.